Hi guys. I have no idea if anybody's going to show up today, but math chats, here we come. Okay, I was 2 minutes late, so I apologize. Moving my board and freaking out my dogs. Sorry, Mai. You're okay, baby girl. You're okay. Oh. Okay, so this is for the Math 8 portion. Hopefully you did okay on your test yesterday. It is all of what we learned. The biggest problem was, oh, that was a horrible line. That's okay. Excuse my hypotenuse. It was very ugly. The whole triangle is ugly. Okay. So if I draw this straight down and still it's ugly, but it's better than nothing. Okay. So some of you had, oh, I'm just going to pick a Pythagorean triple because I know what the answer is going to be. Some of you forgot that the hypotenuse is always the longest side. And when you did this, you actually did, because for some reason you like your x off to the side, you guys went ahead and did 5 squared plus 13 squared equals x squared. You got 25 plus 169 equals x squared. Oh, I should probably have my calculator ready and available for us. Or, get out my actual calculator. And that's going to be a 4, 9, nope, 1. Oh, I keep forgetting to use your finger on this. Okay, 194. Oh, that is so close to 16, or not 16, 14. So 194, and take the square root of that. So 13.9. So I could have approximated that. Can you still see that? No. Give me a second and I will. Okay. Now, some of you put this something like that as your answer, but doesn't the hypotenuse, isn't that the longest side? So there's no way that 13.9 could be this side, because 13.9 would make it the longest side, and that would be over here. So some of you knew how to do a squared plus b squared equals c squared, but you didn't do a very good job of going back and reanalyzing your problem. The other issue was reading directions. The other issue was reading directions, and it said to go west and then northeast. Some of you, I don't know why, were going the opposite direction, and I'm not sure what you came up with. But yeah, so maybe when you're doing north, south, east, west problems, that you actually write, you're okay, baby, north, south, east. I know somebody came up with a little way that they learned how to do that. I can't remember what it was. But yeah, there we go. What's the other thing? The other thing on the test was reading, yeah, the other reading directions. It was a tree. I know, look how fancy I can draw. And it was talking about a guy wire coming out here. Was it a tree? I don't know what it was. Talking about a guy wire. But if you had looked in the directions and read the problem, it says there are 2 guy wires. So it wanted this one and it wanted this one. And we did have a problem in the classwork about, or the homework, I can't remember, that we had a badminton court, or I don't know, some kind of fencing or netting, sorry, that they had to have the poles on the both sides. Oh, I know what it was. It was, would there be enough rope in order to do it? And so you had to make sure that you read the directions on that. Okay. You're okay, Mike. You're okay. You want to sit on your, you want to sit over here? My Maya's having a conniption because this board is here. Okay. So next week, we are going to be, what are we going to be watching or doing? Oh, next week we're starting exponents. And just want to, go back to basics maybe. Not sure if you remember much about your exponents from back in the day, but our exponents. If I have this written right here, this right here is called my base. That's my base. And I'm not sure what year in school you may have learned that. I think 7th grade, but I'm not positive. This is my exponent. Right there. And we would say x to the 4th power. This whole thing together is called power. Okay. So what you're going to do operations using exponents. So let's say I have x to the 3rd times x to the 2nd. Okay, well, looking at that, we said that can't add those together because they don't have the same exponents. We did that before, but now as I look at this, I have to actually figure out the simplified form of this. Now, there is a difference when you have a base of a number or numeric base, or if you have a variable as your base. So let's talk about just having our variables as our base. So if I have this right here means an expanded form. Look at those fancy X's on drawing. Look, oh, I wrote too many of them, didn't I? For this first one, it just tells me I have 3. So this is expanded form right there. And then over here, this is its expanded form. But do we really want to have to expand that out every time? Hopefully not. If I look at that, I count them up. I have 5 of those. Maya, you want your bed? You want me to bring your bed over? Okay. Got to give it a break for just a second. Okay. Watch out. Get up for a second. Get up. Move over. Move over. Now, come here. Sit down. Sit down on your bed. Come on. Okay. Sorry about that, guys. Now, let's look at it again. Let's do it again with another variable. Sit down. So no, come here. Do I really, I'll make it 8 times x to the 2nd. If I have that, I would have to write this x out 8 times. One, 2, 3, 4, 5, 6, 7, 8. And if I did that, then I have this one where it says 2 more. What's the total amount of x's I have? I should have 10. Let me look at x to the, I want to do this. We'll do that. Now, we look at something like this all the time. 2x, okay? Not a big deal. But this one totally tells you that there's an invisible little 1 right there. Okay, I know you can't see it probably. Sorry about that. I'll even make it a bigger one so you can see it. So I have X that's right there. I have 3 more X's that need to be multiplied together. And this over here tells me I have 5 more. So when I count all those bad boys up, hopefully I did not get 4 and I got erased. Who knows where 4 came from? That's my new favorite number today because I keep writing it. To the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. Voila. Do you notice anything about these exponents and this exponent? These exponents and this exponent. Let's change it for a second. And let's see. What if we have a number there instead of a, so 2 to the 3rd times 2 to the 4th. Okay, 2 to the 3rd. 1, 2, 3. If you can't see my little dots, they are there. Then I have 4 more. Now, sometimes, I'm not even going to go there yet. I'm not going to go there yet. I'm going to move this a little bit closer. You're okay. And how many 2's do I have? Hopefully you see that I have 1, 2, 3, 4, 5, 6, 7. Did what you said on the last one about the exponents work here? Did you notice that I kept the base? The base did not change at all. This is called simplified exponential form. That's called simplified exponential form. Sorry, guys, my phone's going nuts. Okay, let's look at another one. 3 times 3 to the 5th. Now, some people tell me the answer to this is 3 to the 5th, but that's not true because you have to remember that you have 1 3 there. So I have to write down that 3. It doesn't go anywhere. Then 1, 2, 3, 4, 5. So how many total 3's did I get? I got 5 of them. Oh, I did not. Look, 1, 2, 3, 4, 5, 6. Hello. We have to be able to count. It makes so much more sense to count because there are 6 of them. There are 6 of them there. Again, this is in simplified exponential form. Okay, because it has an exponent, it's called exponential form. Now, hopefully, when we did this, hopefully we kind of come out with the same answer. So x, 1, 2, 3. So I have 5 of those. Over here, I have 5 of those. Again, this right here and this right here are called simplified exponential form. And unless you know what this X stands for, that's all you can do for that one. But over here, 2 to the 5th power in its simplified form is 32. So this is simplified form. Down to an actual product. Because 2 times 2 times 2 times 2 times 2, that would come out to be a product. Its actual product is 32, so that's its simplified form. Now I'm going to change it just a tad. Oh, I never even talked about the rule. I'm going to erase this right here. Okay, a minute ago we said this came out to x to the 5th. This came out to 2 to the 5th. Now, how did I get that? I write the base. I write the base. Then, if I look at the exponents, I add the exponents. I add the exponents. And you get your answer. Because think of it. If I had 4 to the 23rd power times 4 to the 130th power, would you really want to write all those out? I don't want to write all those out. So instead of doing that, I write down my base and I do 23 plus 130. And I'll move it down. And no, I am not going to figure out what this is in simplified form. I'm just going to leave it in simplified exponential form. 153. Okay, so that's what you do when it's a product of the product rule. Product rule. X to the m times x to the n equals x to the m plus n. Oh, you can't see that. I apologize. I will even move my, maybe, there we go. It's backwards for me, so it's a little difficult to do sometimes. There we go. So now let's, instead of looking at products, let's look at quotients and what they do. But you do have to remember, 4 divided by 4. 4 divided by 4, that gets 1. So 4 divided by 4 is 1. Please remember that. Now let's do some of these. Let's say x to the 3rd power over, oh no, I want to make that something bigger than 3rd. X to the 8th over x to the 3rd. That'll be much better. Look at these. Trying to make it better for you to see like so. Oh, then you don't get to see me. I know, you're so saddened by that. X times x, I'm not going to write that or say that. 7, 8. 1, 2, 3. Okay, so when I do this, this cancels with this. X over x is 1. Then this cancels here. Those are 1s. These cancel here. Those are 1s. So what do we come out with our answer on this? We come out with x to the 5th. Okay. You're looking at it? Are you seeing anything? Yeah, let's look at another one. Y to the 3rd over y. So I have 1, 2, 3 over one of them. That cancels out. Those become 1s. So my answer on this is y squared. Then I have, I don't know what. How about I have 5 to the 4th over 5 squared. On this, 5, and then 5, this ones, these cancel, those are ones, left with 5 squared. Look at what happened. Pretend like there's a 1 here. Look at these exponents compared to this exponent. Look at these exponents compared to this exponent. Okay, and before I give you the rule for that, I have, I don't know, 12 to the 5th over 12 to the 2nd. I don't know. Just picking numbers. So I have 12, 4, 5. I guess I could read that whole thing. So this cancels, I get ones. This cancels, I get ones. What am I left with? 12 to the 3rd. Now, are you noticing when we do these that the 12 is still there? The 12 didn't change away. Didn't change. Okay, look at the exponents. Did they do what you thought they would do? So this is called the quotient rule. I can't spell today. X to the A over X to the B. And what did they do this time? Well, if you look at it, I kept the base and I subtracted the exponents. So over here, it's going to be X to the A minus B. You subtract those exponents. Okay, so let's try another one of those without writing the whole thing out. So I have 4 to the 5th power over 4 to the 3rd power. I'm going to make it 15th power. That's better. 4 to the 15th power. Instead of writing it all out, I'm going to write 4 to the 15 minus 3. All I do is subtract my exponents. You have to keep the base. I can't spell base. Keep the base. You don't change the base. So you get 4 to the 12th power. If I had X to the 23rd power over X to the 11th power, again, you write the base. 23 minus 11. So X equals 12. I know today it's not as much fun because nobody came to visit or nobody's saying anything. I have one visitor, but nobody's saying anything today. Okay, that is what you're going to be mainly dealing with next week. But what I want you to be careful about when you're doing these is you have to make sure that the bases are actually the same. Because if I have 4 times 2 to the 3rd power, are these bases exactly the same? No. 4 is a totally different answer than 2. Now, you could do this problem one of 2 ways. One way is you can make 4 into 2 squared times 2 to the 3rd. You could do that. Then you get 2 to the 5th power, which is 32. Or you could just make this at 4, leave it as is. 2 to the 3rd power is 8, and you still get 32. It depends on what the question's asking for. If it's asking for you to leave it in exponential form, you would want to do this. But if it's just asking you to simplify, you would do this. Now, there's one thing that no, I don't want to do that, but I will do this. Let's try this. What do I do? Let's see, 4 times 6. Now, when we do a problem like this, this is 4 times 6 on top. 3 goes into this. 3 goes into this. Oops, but only twice, not 3 times. There we go. So then I have 4 times 2 over 3. And I get 8 over 3, right? You've been doing that for a long time. There's nothing new about that. You have to remember that when you're doing things like this. 7 times 3 to the 6th power over 3 to the 3rd power. So you have to remember this 7 has absolutely nothing to do with what you're doing with those two. So the 7 just gets written out here. You don't do anything with the 7. It's the ones that have the like bases that you're going to subtract their exponents. So then I have 7 times 3 to the 2nd power. And make sure that you do exponents before you do multiplication. So you do 7 times 9, which gets you 63. Okay, still don't have any questions? That makes me sad that there are no questions. Okay. That's okay. Some of you guys will be able to watch it later on, and maybe it'll help with your homework. Okay, so we may be changing math chats to only be Tuesday, Thursday, and then if you want something on Friday, we can do something on Friday. But for right now, the math chats are going to just be on Tuesday and Thursday. We'll send you out a link as to who's doing it when, because now that we're on our stay-at-home thing where we can't go to other people's houses unless it's 10. I guess we could still do it, but we don't really want to infect other people. So we're just going to stick with this. But anyway, this next week you're going to be dealing with the product rule and the quotient rule. So hopefully those of you that look at this video later, that you might actually get some use out of it. I can't remember who will be on first next week. Probably Mrs. Farrell or Mrs. Rippey. Oh, it's probably Mrs. Rippey on Tuesday. And then Thursday, I believe, is Mrs. Shaw. Then the following week is somebody. Can't remember. Mrs. Farrell, then me. But if you have questions before then, not a problem to ask. Okay, we're going to switch modes. I'm going to switch it to algebra. So this class is algebra. Algebra. Anything on the test that was bad? I don't remember what was on the test that you guys had issues with. Let me look real quick. Look back. We'll go with this one. And the main issue was this problem. Let's see. Okay, so how to move something. Okay, so if something is already sitting up here, you have to know what that vertex point was. Say it's 4, 5. And if I tell you to move it down 8 and to the left 7, that means I'm going to be subtracting 7 from here and subtracting 8 from here. So my new vertex point, oh, it helps if I'm actually looking to see if you guys can see what I'm doing. So my new vertex point would be at -3. And then, oh, that's nice. I didn't even do that on purpose. -3, -3. So if I was to do my equation, oops, it would look like that. So you had to make sure that you started from here and didn't start from the origin because it was talking about this. Let's see, anything else I saw was an issue. That is the main issue. But let's look at this one just in case. Oh, that one does the same thing. Oh, that must have been like the big issue. You have to make sure that you know where you're starting from. Let's see on this one. Let's see. Okay, so if I was to give you, and I don't know, I'm just making something up, so it may come out horribly. So if I gave you this, to find the vertex point of this, the axis of symmetry is -4, because that's negative b over 2a. So hopefully you would have noticed that this would come out to -1. So from my vertex point, we know it's -1. If I was to plug -1 in, that would get me 2 times -1 squared plus 4 times -1 minus 3. Okay, you can still see it. So this is 2 minus 4 minus 3. So that's going to be, let's see, -2, -5. So then you could graph that as the vertex point. What other thing do we know? We know that this is the point 0, -3, vertex point, sorry, and this is y-intercept. So we know those points. So if you look at a graph, you should be able to tell, oh, that and this right here is positive, so that we know it's going to be concave up. Okay, so I really taught my kids how to do this. I hope they remember how to do this, but I want to go over this again. Oh, let's just pick an obnoxious number. It doesn't matter. So if I want to find the x-intercepts, that means 0, something. Nope, that does not. Something, 0. That means that my y value is going to be 0. So I need to change this y value to 0. Okay. Then, if I add 40 over here, told you it's going to come out nasty. I'm just letting you know ahead of time. Divide both sides by 2. That's going to become 20. I take the square root of both sides of the equal sign. And this gets me plus or minus. Now, simplifying this radical. This is a 4 goes into that, a 5 goes into that. So this would be 2 radical 5 equals x minus 1. Guys, plus minus just means that you have a positive and you have a negative. That's all that means. And then if I add 1 to both sides, if I do that, I have 1 plus or minus 2 radical 5. Now, we almost, I shouldn't say almost, we always write it in this form where the rational number comes first and the irrational number comes second. So those are my answers. Well, that doesn't mean anything to me if I'm wanting to graph that. So the thing is with this, you can take your calculator, and yes, normally I have my normal calculator. 1 plus 20 square, oh, I messed up. 1 plus 20 square root, not square, equals 5.5-ish. And then 1 minus 20 square root equals negative 3.5. Now the only reason that I didn't leave it in just this form right here is because it's going to ask me to graph it. Normally I would just leave it in this. I'm okay with that. And putting it in the parentheses, I'm okay with that. But if I was to graph this, I really and truly need to have, because do you know where that point is? I don't know where that point is. So we really need to have that. So the other point that we can have is the vertex point. Well, I look up there and I've got 1, negative 40. Then if I plug in 0 for x, what do I have? Well, that would get me negative 1 squared, which is 1, times 2, 2 minus 40. So if this is my vertex point, this is 1 over. So the mirror of that would be 2, negative 38. So we have 1, 2, 3, 4, 5 points, and we can graph this. Okay. Let's look at your homework, because I was just doing your homework. Here, what happened to my page? I was just on it. Page 511. Here we go. One of the things that I think might be difficult is you remembering how to take the square root of something. So if I have the square root of 36, bam, easy. The square root of 100, bam, easy. The square root of 196, bam, easy. Those are the easy ones. Okay? If I have the square root of 4 plus the square root of 4, 2 plus 2 gets me 4. The square root of 64 minus the square root of 36. I get 8 minus 6, which is 2. Okay. Now I know I'm saying okay again. And so let's look at this. The square root of 28. You have to know what goes into 28. Now, I've always done it this way. And then thought of it as the square root of 4 times the square root of 7. So that's 2 radical 7. Do I have to write that times there? No. But that's what it stands for. But some of you didn't like that way. That's perfectly fine. I don't care if you don't like it that way. You can do it your way. Perfectly fine. Not an issue with that at all. Do it how you like it. Do it how it's easiest for you. So this is the same thing as 2 times 14, 2 times 7. So you've got your factor tree. Bam. 2's on the outside, radical 7. Did we get the same answer both times? We sure did. So let's do a few others of those. I'm very sad nobody came to see me today. It's probably because you took a test yesterday and you didn't want to do this, or you thought the assignment was easy. So 20 square root of 24. 2 times 12. 2 times 6. 2 times 3. Right there. So I've got 2 radical 6. Pretty easy peasy lemon squeezy. I know some of you are like, Miss Grandpa, this isn't easy peasy. But yes, it is. Okay. Let's pick another number. Oh, what number do we want, Maya? Bed. You guys outside, the gardeners are scaring you, huh? The gardeners scaring you? I don't know why they're out there mowing wet grass, but that's okay. Let's do 200. Now in my brain, I see that as 2 times 100. But some people can't do it like that, so that's okay. So 2 goes into 150 times, 2 goes into 50 25 times, 5 and 5. Now be careful because you're going to do this and you're going to do this. Don't forget that you have a 2 right there. Can't forget that little 2. So I have a 2 from here, I have a 5 from here, and I have a 2 underneath. Right, there we go. 10, radical 2. Okay. I can't believe Mrs. Shaw isn't watching this and helping me. I'm gonna send all of them a text. None of you guys are on math chats with me. Okay, let's see. Let's take the square root of, how about just 50? 2 times 25. Oh, we just did that just then. We have 5 and 5. So 5 radical 2. How about if we do this? Ooh, I like this one. This is one of my favorite ones. 48, the square root of 48. So if I take this, I get 2 times 24, 2 times 12, 2, I really don't like it this way, 2 times 6, and 2 times 3. Here we've got a 2, here we've got a 2. I'm telling you guys, if you could learn the other way of doing this, it's so much simpler. So then you get 2 times 2, and you have a radical 3. So 4 radical 3. I'm all by myself. Nobody's here. Somebody's here now. I see somebody showed up. I think it's Mrs. Farrell who showed up. Okay. Let's see. I'm purposely doing the square roots because I think we've forgotten how to do our square roots. And so that's why we're doing these. So I don't know. Pick a number, Mrs. Farrell. What number should I do? I'm going to pick one. Well, I'm waiting for hers to come through. Did it come through? Oh, 52. Oh, I like 52. And once you've been doing this for, 50 years, this becomes easy. So again, I know you guys like the factor tree way. So 2 goes into 52. Oh man, I don't remember what that is. 2 goes into 5 2 times with 1 left over. 2 goes into 12 6 times, so 26. 2 goes into 26. 2 goes into 2 once. 2 goes into 6 3 times. Voila. I have my 2s. They go on the outside. And our 13 stays on the inside. Yeah, Mrs. Farrell, I figured it was just taking a while to show up. So I like this number. Actually, that's not the one I really like. I like this number. 2 goes into it, but why did I start with 2 and not 3? Because doesn't 3 go in? Because my brain, I do whatever the smallest number first is. Does it matter? No, I could have started with 3 right here. So 2 goes into that. Oh, let's see. 2 goes into that. Oh, that's too hard. So let's try 3. 3 goes into that. Oh, that's easy. 3 goes into that. Oh, so much easier. Okay, so it doesn't matter which direction you go. I just like to go with 2's first. Oh man. Look at all those 2's. That's why I like this number. Again, if I do this, does 3 have a partner in crime? It doesn't. I'm going to write it over here just because I don't have room. So I have 2 times 2, and then I have the 6 on the inside. So my answer is 4 radical 6. Did I do okay? Does it look pretty? I hope so. Hi, girls. Let's see. This is the hard one for some people. This is a hard one. And once you figure it out, it's actually pretty easy. Oh no, that's not the super hard one. I know the super. This one still 2 goes into. And you're like, oh man, that's easy. But you never seem to know that it's 49. And that's just 7 and 7. So 7 radical 2. Try this one. For the longest time, I could never figure out what goes into this number. Man, what goes into that number? Does anything go into 111? Yeah, 1 goes in, but 2 doesn't. 3 doesn't. Oh, be careful with your 3's because add these numbers up. 1 plus 1 plus 1 gets 3. So that means 3 does go into this. Oh, but how many times does 3 go in? Now, I don't know if you saw the way I did it, but 3 goes into 11 how many times? 3. With how many left over? 2. 3 goes into 21 7 times. Did I do that right? Well, if you don't know if you did it right, couldn't you just multiply it back out and see if you got that number? Oops, I just totally hit my computer. Oh, but both of those numbers are prime. So amazingly simplified form of that is 111. Come on, baby. Super pretty. My board is super pretty. My house that has no light is super pretty. The dog is pretty. That's what it is. Let's see. What else do I want to do? Okay. Now, let's talk about this number. Yes, 5 is on the end, so automatically 5 goes into that. But I want you to, when you have a big number, let's see if there are other numbers that go into it. If I look at this right here, I have 75. Any number that ends in 00, 25, 50, or 75, all of those are going to be divisible by 25. Every single one of them. Oh, I'll do that one in just a second. So now, do I know this off the top of my head? No. Well, I could say how many quarters are in $5.75. That's easy. Because $1 you have 4 quarters, $2 you have 8 quarters, $3 you have 12, 4 you've got 16, 5 you've got 20, and then isn't that 3 more? So 23. That was a horrible too. I know, don't use your fingers. That's a prime number. 5, 5, 5 radical 23. So anytime it ends in those, you know you can take out at least the 25 or the 5. Take the square root of the 25. So let's try it. Mrs. Fair Girls for the last 1234. I just did division. There we go. Oh, man. That's hard. That's a big number. Well, it's even, isn't it? So we know for sure that 2 goes in. 2 goes into 12 6 times. 2 goes into 3 1 time with 1 left over. Oh, man. Whew. I don't know what goes into that. Let's see. Does 2 go into that number? Okay, so 2 doesn't work because it's not even. Well, let's try 3. 6 plus 1 is 7. That's 14. 3 doesn't go into 14, so it's not that. 4. Well, if 2 doesn't go in, that means that, sorry, if 2 doesn't go in, that means 4 doesn't go in. 5. Well, doesn't end in a 5. Totally not going to be it. 6. Well, guys, if 2 doesn't go in, doesn't that mean all of the even numbers don't go in? So let's try 7. Well, let's see. I don't know. So I have no idea what goes into this number. So that goes in 8 times. So that's, I know some of you don't know how to even do this. So that's going to give me 57. Does 7 go into 57? Nope. So it's not going to be 7. Can't be 8. Can't be 9. Can't be 10. Well, let's try 11. So 11 into 617. I can tell you what the answer to this is. That's 55. I borrow. I get 67. Yeah, that's not going to go in evenly. So it's not going to be 11. So our next prime number is 13. 13. Well, 13 times 2 is 26. 13 times 3 is 39. 13 times 4 is going to be 52. So that goes in 4 times. That's a 52. This gives me 67. Does it go into 67? I don't think so. Man alive, Mrs. Farrell. I don't know what goes in. I actually don't know what goes in. Let's use an actual calculator. Did I do the problem right? 1, 2, 3, 4 divided by 2. Just make sure I got that right. Divided by 17. Nope. Dude, help me. What goes in? 23? No. 6, 17. Are you laughing at me? Okay. I don't, Miss Farrell, hello, help. I actually don't know what goes into that. 617 divided by 617 divided by, I'm right here, sweetie pie. Yeah, I'm thinking it's a prime number too. Divided by 23. Yeah, it's going to be prime because 23 and it's 26. So, smarty pants. Rat. Can't take the square root of that. She's mean to me. Okay, anything else I should go over, Mrs. Farrell? I went over vertex form. They're taking the square root on their homework. My fingers are all dirty. Yeah. Anything else I should say? You guys did really good on that test, by the way. I mean, we didn't have all hundreds, obviously. Okay, I'm going to sign off then because we're just it. Thank you, Mrs. Farrell, for coming to play. Enjoy, guys. All next week will be great.